Let's study the three processes involved in rainbow formation. Step 1 is refraction, or the bending of lights. When sunlight passes from air, which is a less dense medium, into water, a denser medium, it slows down and bends. This fundamental process is called refraction. Different colors bend by different amounts because each wavelength travels at a different speed in water, a phenomenon known as dispersion. So here is a key fact. Violet light bends the most. Red light bends the least, creating the initial separation of colors. Step 2 is internal reflection, or reflection inside the raindrop. After light enters a raindrop and undergoes its initial refraction, or bending, it continues its journey towards the back surface of the droplet. This is where the second critical step in rainbow formation occurs: internal reflection. This bending is also wavelength dependent, a phenomenon known as dispersion. Each color or wavelength of light has a slightly different refractive index in water, meaning each color slows down and bends by a slightly different amount. Violet light, having shorter wavelength, interacts more strongly with the water molecules and experiences a greater change in speed, thus bending more than red light, which has a longer wavelength. The reflection of lights off the inner surface of the raindrop is a key event. This is not just any reflection. It's a phenomenon called total internal reflection, or TIR. Step 3, refraction again. It is when light exits the droplet. As light exits the water droplet and re-enters the air, it refracts a second time, bending once more and further separating the individual colors. This double refraction, combined with the internal reflection, produces the concentrated spectrum of colors we perceive as a rainbow, a perfectly orchestrated dance of lights and water. The result is a clear separation of wavelengths, with each color emerging at a slightly different angle from the droplet. And this is why we see a full rainbow. When do rainbows appear? For a rainbow to appear, 3 important conditions must be present. Number 1, the sun must be shining. Number 2, there must be rain or water droplets in the air. And number 3, the sun must be behind you while the rain is in front of you. So first, the sun must be shining because sunlight is needed since a rainbow is made from lights. Second, there must be rain or tiny water droplets in the air because these droplets act like small prisms that bend and reflect the sunlight. Third, the sun must be behind the observer while the rain is in front. When sunlight enters the raindrops, it bends, reflects inside the drops, and bends again as it comes out. This process separates the light into different colors, which we see as rainbow. This is why rainbows often appear after a rain shower, especially in the morning or late afternoon when the sun is low in the sky.
How rainbows are formed. Let's unravel the magic together. When sunlight hits a rain droplet, some of the light is reflected. The electromagnetic spectrum is made of light with many different wavelengths, and each is reflected at a different angle. Thus, spectrum is separated, producing a rainbow. Red has the longest wavelength of visible light, about 650 nanometers. It usually appears on the outer part of a rainbow's arch. Violet has the shortest wavelength, about 400 nanometers, and it usually appears on the inner arch of the rainbow. Actually, all rainbows are full circles. But most people only ever see an arc or semicircle, because they are standing on the ground and the other half is cut off by the horizon. If you see a rainbow from an airplane, you might see the full circle. Did the magic of rainbows captivate